This is the Earth. We can easily study its surface, but how can we explore its depths? Well, one way is through high pressure and high temperature experiments, as presented in this video. Another way to investigate the interior of our planet is by studying natural samples that form there, such as diamonds. When we think of diamonds, we often picture shiny and perfectly cut gemstones, right? However, rough diamonds are quite different. They can look like this, or like that, and these are the most fascinating ones for geoscientists. Diamonds form in two different deep regions of our planet. The most abundant ones form around 250 kilometers in the lithospheric mantle. The rare ones, known as super deep diamonds, are formed at 350 to 700 kilometers, reaching the mantle transition zone and lower mantle. To put it in perspective, if we think about the tallest mountain on Earth, Mount Everest, with a height of around 9 kilometers, the region where super deep diamonds form is equivalent to about 40 to 60 Mount Everests stuck together deep within the Earth. Super deep diamonds are the only natural samples that allow scientists to investigate such deep parts of our planet. When these diamonds crystallize, they trap other minerals in their structure, acting as a time capsule, enabling scientists to study these minerals millions of years later. These inclusions can provide insights into past events that have contributed to the evolution of our planet. To reach these tiny inclusions inside the diamonds, it's important to use non-destructive analytical techniques that preserve the chemical and physical conditions of the trapped minerals. Thus, we have chosen to analyze them using a special machine, a synchrotron. Synchrotrons are huge donut-shaped particle accelerators that accelerate electrons to very high speeds, close to the speed of light. Using special magnets, these electrons are forced to change their trajectory, and as a consequence, they emit a brilliant and powerful light called synchrotron. Synchrotron light is an electromagnetic radiation that can be transmitted through materials, enabling us to observe what's inside diamonds without the necessity of breaking them. With synchrotron, we can do several X-rays analyses using spectroscopic and diffraction techniques that allow us to detect the mineral phases inside the diamonds, as well as their chemical composition, redox conditions, and so much more. Moreover, investigating inclusions in diamonds at the synchrotron may help us to discover new mineral phases never reported on Earth before, for instance, like ringiodite, a mineral previously only found in meteorites or synthesized in high-pressure and high-temperature labs, which was identified by scientists as an inclusion in a super-deep diamond, confirming its natural existence. In summary, we can confirm that diamonds are great tools to see what's going on inside the Earth. I am pretty sure that you'll never see your diamond jewel the same way, right? Thanks.